K-Water is a public company specialized in water resources management. We provide various international water education programs for the developing countries to solve water-related issues all around the world. Today, we will learn about the theory of water resources and hydrologic investigation basics. Firstly, water resources refer to water that can be used in various ways to maintain human life, economic activities, and natural environment. Water is treated, consumed, and used from dams, streams, and estuaries to various areas such as cities, rural areas, industrial complexes, and non-water supply areas in a river basin unit. And all activities to collect and analyze information on water resources and to find out the fundamental status of river and river basins are called water resources surveys. The water resource surveys include a variety of investigations such as drainage basin, hydrological processes, underground water, water quality, and river environment change, etc. These water resource and hydrologic investigations provide basic data required for planning water resources. Typically, ASCE emphasized on the importance of hydrologic investigation with a mention as a design error due to the wrong use of hydrologic data leads to a great damage. The investigation is cost-effective. Then, what is hydrological investigation? Hydrologic investigation refers to the observation and measurement of hydrologic factors in order to quantify the hydrologic cycle process. When conducting hydrologic investigations, the water level, discharge, and sediment from rivers and lakes, as well as the intake and effluents from these sources, and the precipitation, evapotranspiration, and soil moisture content of river basins are observed, measured, investigated, and analyzed in scientific ways. A hydrologic investigation should be conducted very precisely for efficient use of limited water resources compared to increased demand. If the observed value is smaller than the true value, riverbanks may overflow and dams may be discharged frequently. And accurate water management, such as dam operation, can be hard due to errors in flood forecasting. On the other hand, if observed value is larger than the true value, national budgets can be wasted due to excessive design. An overvalued discharge rate can cause confusion in river management. If data is missing or insufficient, a lot of confusion related to water resources can be triggered, and it is hard to manage water in real time. The hydrologic investigations of 2017 in Korea was managed as shown in the table. The entire hydrologic data includes nationwide precipitation, water level, discharge, sediment, soil moisture content, and evapotranspiration, which are obtained by the government and various specialized organizations. So, how can the hydrological data be utilized? First, these are used for water resource planning and management, and the dam and reservoir operations and water utilization. These are used for flood and drought analysis, drought forecast, flood control planning, and flood control structures design and operations in water management. Also, these are used for river and discharge management, river environment design and management, and total maximum daily loads management in environmental management. Lastly, these can be used for leisure life, etc. Precipitation management is one of the hydrologic investigation items. Precipitation refers to the value marked in the depth per unit area of the amount of rain, drizzle, hail, frost, snow, and soft hail that fall over a certain period of time, which can be divided into rainfall and snowfall. In Korea, a conductive magnetic precipitation gauge system is commonly used to measure precipitation. The system collects rainfall and snowfall through the water intake and outputs a contact signal as a tipping cup is conducted when precipitation is 1 millimeter. The precipitation gauge system also measures the amount of snowfall with a heater inside the water intake and cannot measure conduction less than one time. In addition, as buckets require even a short time for conduction, any additional rain at conducting moment must be carried away. Thus, the precipitation observation stations should be carefully installed considering many factors as below. Observation values at the place shall represent the precipitation in the area, considering the observed density and altitude. A station shall be in a flat and open area, less affected by buildings, trees, and forests. If the station is within a 10-meter radius of a flat area, it shall be located in at least twice higher than the nearby obstacles and have less atmospheric changes. Also, it shall be easy to install, maintain, and control observation facilities. Lastly, a station which is not likely to be flooded shall be installed slightly higher than a drainage facility and water level ground. Given the above conditions, the first, second, and third locations are not suitable for the observation station due to surrounding buildings or trees. And the fourth location in the flat and wide area is the most suitable. Now let's take a closer look at the water level measurement. Water level refers to the height from a certain reference surface to the surface of a river, and the average sea level of Incheon Bay is used for the height reference in Korea. A normal water level meter is a device marked with a scale so that the staff can visually check it. And a watermark is usually used. Also, a magnetic water level meter with recording equipment is classified into a contact and non-contact meter. A contact type includes floating, pressure, and bubble meters, and the non-contact type is an ultrasonic meter. When establishing a water level observatory station, many factors should be considered, such as timing at which permanent observation is required according to the purposes such as river development, management, river maintenance plan, water resources development plan, and structures construction, etc. Accurate measurement with constant water flow, flow velocity, and gentle slope, unchanged water path and riverbed, and straight upper and lower channels. Based on the above conditions, the fifth area with a stable flow and straight channel is the most suitable for installing a water level measurement station. Let's talk about discharge measurement. Discharge means the amount of water passing through a cross-section in a unit time. Discharge measurements is done by current meter, weighting method, and bridge method depending on field conditions. And current meters are classified into rotary meter, electromagnetic meter, ultrasonic acoustic Doppler current profiler or ADCP meter, and electromagnetic surface meter. Discharge can be investigated through various methods like walking, bridges, ships, and cableways. When installing discharge investigation stations, the same matters should be considered as those of water level observatory stations. The important things to remember are condition before and after division and confluence of major streams, reservoirs, retarding basins, and upper and lower reservoirs, canyons with straight channels. And the areas to avoid are river junction and direct upstream channels, tidal section of river estuary, rapid meandering river section. Next, we're going to learn about sediment measurement. Sediment refers to the amount of soil per unit time transferred by the flow of a river, and is divided into bed load and suspended load sediments according to the transport type. Bed load means sediment that rolls or slides on the riverbed surface or moves along the riverbed surface. Suspended load is sediment transferred by floating on the surface. The bed load sediment measurement aims to identify the flow characteristics such as tractive force and bed load discharge relation and bed load transfer features. And the suspended load sediment measurement is conducted to identify the flow characteristics, such as discharge and suspended load transfer characteristics. Sediment is measured by lowering or raising the sampler according to each section of the river. Depending on the field conditions, both the suspended load sampler and discharge measurement can be used simultaneously. For measuring sediment, depth-integrated sampler and drop-integrated suspended load sampler are used. Next, let's take the soil moisture content measurement. Soil moisture content means the amount of water in the soil. There are two main methods for soil moisture content measurement. One is a direct method of evaporating water by collecting soil from the site, and the other is an indirect method of measuring changes in soil moisture with sensors. The indirect measurement contains electric resistance measurement, dielectric constant measurement, radiation measurement, and remote sensing. Currently, K-Water is managing a soil moisture station. We're using the time domain reflectometry, TDR sensor to measure dielectric constant. A soil moisture observatory station should be installed in a place that represents soil, geology, vegetation, weather, etc. in the surrounding area. A place where relatively homogeneous soil layers are positioned with a sufficient depth to observe horizontal and vertical spatial behavior of the soil moisture. And a place in which installation, maintenance, and management are easy and stability is secured. Lastly, let's see at the evapotranspiration measurement. The evapotranspiration is the sum of the vapor that evaporates from the ground or from the water to the atmosphere and the vapor that evaporates from the leaves of the plant for a certain period. Evapotranspiration can be measured by water balance, energy balance, aerodynamic calculation, eddy covariance method, and evapotranspiration flux tower. Let's take a look at eddy covariance method. This is a micrometeorological method to estimate evapotranspiration by measuring turbulent flux in homogeneous areas. And an evapotranspiration observation tower, flux tower, is installed for the measurement. The image above shows the K-Water's evapotranspiration observation station. Based on data measured by 3D wind direction anemometer, gas analyzer, and various micrometeorological equipment installed in the flux tower, observations can be made through eddy covariance method. An evapotranspiration observatory station should be installed in a place that represents soil, lipids, vegetation, weather, etc. in the surrounding area. A place where the surrounding area is flat and homogeneous. However, exceptions are made when it is installed in a mountainous area for special purposes, such as measuring evapotranspiration of mountains. A place not affected by individual obstacles, such as trees, buildings, etc. A place in which installation, maintenance, and management are easy and stability is secured. So far, we've learned about the theory of water resources and hydrologic investigation basics. Thank you.